Hello, I'm Jenny Grossleit with Agilent Technologies, here to show you how you can save time using the DDR Setup Assistant. Today's demonstration will use the U4154A, the fastest logic analyzer in the world. DDR Setup Assistant speeds the setup for DDR measurements. Typical setup of a DDR3 system will take under 15 minutes. Setup for this DDR3 2340 example took under 6 minutes. DDR Setup Assistant offers ease of use. There are 9 simple steps, semi-automated, for DDR3 or LPDDR2 state mode measurements. It is for use with the U4154A or 16962A logic analyzer modules. DDR Setup Assistant shows up as an icon on your screen once you have loaded the DDR iFinder software. Click on the DDR Setup Assistant icon to get started. The first of the 9 easy steps is to specify your input parameters. Here we have one logic analyzer module set to choose from. We're going to probe DDR3. We're using a DIMM interposer, and we're using the Nexus DIMM interposer. The next step is automated. We'll load the default configuration for the Nexus interposer. Hardware setup is a help document that guides you through connecting your specific probe to your logic analyzer. After hardware setup, the next 3 steps, setting initial thresholds, setting sample positions for clock and chip select signals, and setting the sample positions of address and command are all automated. They're separate steps because the tool is using different scan triggers for each of the steps. Finding latency values is a step where you input your CAS latency and your CAS write latency. If you don't know your latencies, there is a help document to help guide you through different methods to obtain the latencies. Step 8 for finding the data read and data write eyes, and the last step, you save your configuration. You'll be able to use the sample positions DDR Setup Assistant chooses for clock, chip select, command, and address. On the really high data rates, it's a good idea to go in and check the eyes for the data read and data write. Here on the data reads, I've narrowed the span to be just the area 0 to plus 2.5 nanoseconds, where we see the data bytes occurring. This lets us see the eyes better when they are so small at these high data rates. The composite signals do not show an eye because the eyes are very small and overlap. There are no check bits in this system. But we can see the byte lane activity of the composites. And then when we open up an individual byte lane, for example here, byte lane 5, we see the individual eyes. And then the composite of byte lane 6 and its eyes, and the composite of byte lane 7 and the eyes for byte lane 7. Also notice that the strobe should be corresponding to the sample positions for their specific byte lane. Typically, iFinder mode is all you need for setting up sample positions to take state mode measurements. If you want to see bus level signal integrity insight with full scans, you can now bracket the measurements for the scan range. Here I would choose the 0 to plus 2.5 and go to the hot button for doing full scan and then showing full scan. And actually scanning the full scans will take a little longer. The time-only scans are sufficient for making state mode measurements, and we're ready to run our logic analyzer. State mode data can be viewed in the listing window, or we can view the data in the waveform window where we can see the state mode waveforms or the timing zoom waveforms. Thank you for watching. For more tips on how to make better memory measurements, please go to the link shown below. To learn more about the world's fastest state mode logic analyzer, go to the U4154A page shown below.